Hello seniors, today we're going to see electronic assignment number 3, which is arithmetic sequences. Remember that yesterday you've seen the lesson for patterns and sequences. So we've seen the concept in general of what a pattern or a sequence is. So today we're going to get into a special type of sequence, which is called the arithmetic sequence. We're going to study in depth two types of sequences, the arithmetic sequences and the geometric sequences, which we're going to be studying during the following classes. So for today, arithmetic sequences. The objectives for this class, the first one, use the formula of the nth term of an arithmetic sequence, and the second one, apply arithmetic sequences to solve problems. So let's try to understand what an arithmetic sequence is first. So pay attention, it says, given the sequence 8, 11, 14, 17, can you see the pattern here? We're increasing each term by 3, right? 3, 3, 3, and so on. This is, as I told you, this is called an ellipsis. It means that it continues until infinity. So the value of each term is 3 greater than the value of the previous term. This is an example of an arithmetic sequence, or also called arithmetic progression. So it says in the red box, in an arithmetic sequence, the terms increase or decrease by a constant value. This value is called a common difference, or D. The common difference can be positive or a negative value. Okay, let's see some examples, and then I'm going to show you the general formula for arithmetic sequences. It says, find the first term, which we call U1, and the common difference, which we call D, of the following arithmetic sequences. So, first of all, how do we know that this particular exercise is an arithmetic sequence? As I told you, because there is a common difference between the terms, right? 14 minus 11 is 3, 17 and 14, this gives us 3. So since there is a common difference between the numbers, we're talking about an arithmetic sequence. Where, what is U1? U1 is the first term. U1 in this case is 8, right? The first term of the sequence. And what is the common difference? What we just found, 3. So in this case, you see that the common difference is a positive value, which makes this pattern increase, right? We go 8, 11, 14, 17. So what do you think will happen if the common difference is negative? The sequence should be a decreasing sequence, like we're going to see now. In this sequence, 35, 30, 25, 20, and so on. U1, the first term, would be 35. And then the common difference, if you calculate the common difference, this is negative 5. Remember, it's always the second term minus the previous term, okay? Not the other way around. We're always going to do the second term minus the previous term. Then this term minus this term, then this term minus this term, okay? Always follow that order. So 25 minus 30, this is also negative 5. And then 20 minus 25, it's also negative 5. So in this case, the common difference is negative 5. And we see that when we have a negative common difference, the sequence is decreasing, okay? Next case. What will be U1 here? U1 is 4, right? The first term of the sequence. Then we can calculate the common difference. This minus this is 0.1. This minus this is also 0.1. This minus this is also 0.1. So we have an arithmetic sequence with a common difference of 0.1. I'm just showing you this example to show you that the common difference may also be a decimal. But as it is a positive decimal number, the sequence is also increasing. And then in this last case, U1, the first term, would be C. And how do we calculate the common difference in this case? We need to do 2C minus C. How much is 2C minus C? It's not 1, it's C, right? So there's a common difference of C. 3C minus 2C would be C. 4C minus 3C is also C. So the common difference is also C in this case. We can have the same number, it doesn't matter. but it's just a coincidence for this example. Okay, so I think this is clear, right? Whenever we are talking about an arithmetic sequence, we will always need to identify the first term, u1, and the common difference, d. Okay, now I'm going to show you the formula to calculate the nth term of an arithmetic sequence. This formula is available in the official formula booklet of the IB. I'm going to show you that in a while. So, this is where the formula comes from. Imagine we have any sequence, or actually an arithmetic sequence, with u1 being the first term, okay? How do we calculate the second term of an arithmetic sequence? Try to think about this example we've seen before. Sorry, this is 11, then 14, 17, and so on. u1 is the first term, right? Then how do we calculate u2? It's just u1, 8, plus the common difference, right? Which in this case is 3, the common difference. So the second term is calculated by doing u1 plus the common difference. That's how we get u2, okay? This is 11. Then, if we follow the same reasoning, we will see that u3 is obtained by doing u2, the second term, plus the common difference. The second term plus 3 gives us 14, right? 11 plus 3 is 14. But from the previous deduction, we know that u2 equals all of this, right? So if we replace the value of u2 by its equivalent, which is u1 plus d, we will get a formula that is u1 plus d again, okay? So if we organize those terms, we'll get u1 plus 2d. And then if we keep on doing the same reasoning, u4 would be u3 plus d, but we know that u3 is this, u1 plus 2d, right? So u1 plus 2d plus d is u1 plus 3d, and so on. We can keep on doing that for the rest of the sequence. So you see the following pattern. If you observe at this terms we have here, you can see that we always have u1, and then we have a number times the difference, right? And that number is always one less than the position we're talking about, okay? If we calculate u3, then this is times 2d, okay? If we're calculating u4, then it's times 3d. If we do u5, then it's times 4d, and so on. It's always one number less than the position we're actually calculating. So the general formula can be written like here. un, which is the nth term of the arithmetic sequence, is u1, which is the first term, plus n minus 1, because remember it's one less than the term we're calculating, n minus 1, times d, which is the common difference, okay? So here you have the key elements of an arithmetic sequence. un is the nth term, u1 is the first term, n is the term number or position, and d is the common difference. Okay, so I'm going to show you you can see that in the formula booklet. If we go to the formula booklet, I have it here. Formula booklet here. If you go to topic number 1, yes, algebra, you see that here you have the nth term of an arithmetic sequence, and we have the same formula I showed you there. u1 the first term, n is the position, d is the common difference, and un is the nth term, okay? So we keep on with this. Erase this. Let's see this example. This is example number 3 of the book, if you want to follow using the book. It says, find the 12th term of an arithmetic sequence, and this is the arithmetic sequence. You see that this problem is already telling us that this is an arithmetic sequence. So we know that the difference between the terms should be a constant, right? What will be the common difference in this case? So let's identify first. What will be u1? u1 is the first term, which is 13, okay? And the common difference is calculated by subtracting the second term minus the first term, or the third term minus the second term, however you want. So this is 19 minus 13, which gives us a common difference of 6, right? So in order to find the 12th term, we're going to apply this formula, and we're going to say it's U12, because we want to find the term in the 12th position, equals U1, the first term, 13, plus n, which is 12, the position, minus 1, times the common difference, which is 6, right? So we solve this. 11 times 6, that's 66, plus 13. This would be 13 plus 11 times 6, 79. So the 12th term of this arithmetic sequence is 79. And then for part B, it says, find an expression for the nth term. That'll be like writing the general formula to solve this sequence. So that'll be using this formula again, and we're going to say un, which is the nth term, equals u1, which is 13, plus n minus 1 times 6, right? And that's it. This is the general formula to calculate any term of the sequence. If you want, you can develop this a little bit by doing the distributive. So we'll get un equals 13 plus 6n minus 6. So un is, this is 7 plus 6n. This will be the expression for the nth term, okay? So that's it for example 3. Then we have example 4. It says, find the number of terms in an arithmetic sequence. So it's telling us it's an arithmetic sequence, so we can find the common difference between the terms. You see that in this case, we have u1, this would be the first term, second term, third term, then we have the ellipsis, and then we have one last number here, which is, this is telling us that 12 is the last term of the sequence, okay? Last term of this sequence. That means that this particular sequence of this example finishes at 12. It does not keep on moving forever. So, we're going to identify once again u1, which is the first term, 84, and the common difference in this case would be 81 minus 84. Remember, always the second term minus the previous term, okay? So this gives us a common difference of negative 3. That means that the sequence is decreasing, which actually is. So once we have u1 and d, the problem is almost already solved. We want to find the number of terms. If we're asked to find the number of terms, what are we being asked? Not the term itself, but the number of terms we have, which would be n, okay? So, we know that the last term is 12, but we don't know its position. So if we apply the formula, remember the formula, I'm gonna bring it here. Duplicate. Here we have the formula. 12 is the last term of this sequence, and this should equal u1, which is 84, plus n, which we don't know, we want to calculate that, minus 1, times the common difference, which is negative 3. Remember parentheses when you're writing negative numbers. So then we have only one variable, which is n, and we can solve for n. This would be 12 minus 84. 12 minus 84 is negative 72, equals, we can distribute this negative 3. We'll get negative 3n plus 3, right? So then this is negative 75 equals negative 3n. So finally n, if we divide both sides by negative 3, we'll get that n equals 75 divided by 3, which is positive 25. That means that this sequence has 25 terms, okay? You could write if you want, there's no need to, but if you want to understand this better, you can write the unit of measurement, which is terms. 25 terms in this sequence. We can make a verification here just to make sure that we did the right thing. So we can calculate, for instance, how much is U25? What is the value of the 25th term of this sequence? So by applying this formula over here, we would say that U25 equals U1, which is 84, plus 25 minus 1 times the common difference, which is -3, right? And if we solve this, this would be 84 plus 24 times -3. And if you do that in the calculator, or if you want to do it mentally, you should get, let me see, 24 times -3, 12. So our answer is correct. We verified that the 25th term of this sequence is actually 12, which is the last term in this example. Okay. Following with example number 5, I think this is the last one. It says in an arithmetic sequence, once again, we're told this is an arithmetic sequence. Normally in IB exam exercises, we're not told what type of sequence the particular problem is. We need to demonstrate what type of sequence it is by doing some calculations. We're gonna see that eventually, but just for you to pay attention to that. Do not assume a sequence is arithmetic if you're not told that the sequence is arithmetic. Okay, so in an arithmetic sequence, U9 is 48 and U12 is 75. Find the first term and the common difference. So the 9th term is 48 and the 12th term is 75. We're asked to find U1, the first term, and the common difference D. Okay, so this exercise is probably one of the most difficult in this topic when you're not given either U1 nor the common difference. So you need to calculate both. And there are many ways we could solve this. I'm gonna show you all the different alternatives. The first one, which is probably the longest and the one I do not recommend, is to write both equations. If we have U9, we can always use this formula. I'm gonna bring it down here. This is a general formula for the nth term. So we could say, for example, that U9 equals U1 plus 9 minus 1 times the common difference. We don't know U1, we don't know D, but we know that U9 is 48, okay? So this is U1 plus 8D. And this would be our first equation number 1. We have one equation with two variables, U1 and D, so we cannot solve this yet. But we can write a second equation with the second piece of information, which is U12, right? So this would be U12 equals U1 plus 12 minus 1 times D. Once again, 12 is 75 equals U1, we don't know, plus 11D. We don't know D, but we have two equations with two variables, right? So we can solve this either using the calculator or doing it manually. If you use a calculator, remember you can do this. I'm gonna show you how to use a calculator for this. I'm gonna write the steps here. It's menu, equation, then you press simultaneous. In this case, two equations, simultaneous. Then number of unknowns would be, it would be 2 unknowns. And then you plug in coefficients. Okay, so remember to respect I'm gonna rewrite both equations. Let me do this quickly. I'm gonna rewrite these equations here, but in the order necessary to plug into the calculator. So this would actually be, I have to erase it. This would be u1 plus 8d equals 48 in the first equation, and u1 plus 11d equals 75 in the second equation. Okay, so just to show you how to use calculator, I'm gonna put the camera on. So this is a calculator. Remember, you're in the main menu. So if you go to menu, equation, simultaneous is F1, number of unknowns 2, and then you plug in the coefficients in the order that is established in the assignment. I don't have the values here, so I'm gonna go back. But you know how to do that there, okay? So the coefficients you need to plug in are 1, 8, 48, 1, 11, 75, okay? I'm gonna take a picture of this just for the record. There we go. That will go to the assignment. Let's crop this quickly. This is how you should plug in the values in your calculator. So then you press execute and you get the two values of u1 and ud. You get that u1 is negative 24. The first term is negative 24, and the common difference is 9. Okay, the common difference is positive. That means that the sequence should be increasing. And from these two values we're given, yes, we can see that the sequence is actually increasing. So the result is most probably correct. Okay. This is one way of solving this. I'm going to show you a second way to solve this using a different color. As I told you, this first way of solving the problem is a little bit long, and I do not recommend this normally. I know why. That's better. Okay, so another way. Another way is to think about the following. This is a more theoretical way of solving the problem. You see that we're given u9 and u12. So in the arithmetic sequence, we should have this order, right? u9, u10, u11, and u12. So we know that between the terms, there is a common difference, right? Common difference, common difference, common difference. So if we subtract u12, I'm going to keep on doing with blue, u12 minus u9, how many common differences do we have between this term and this term? There are 3 common differences, right? So this equals 3d. We know u12 is 75. We know u9 is 48. So this equals 3d. And you see that here we have only one variable, which is d. So if we perform this, 75 minus 48 gives us 27 equals 3d. So finally, the value of d would be 27 divided by 3, which is 9. That's the common difference. And in order to find u1, we can plug in the difference into any of these equations, either this or this. You could pick that. So I always recommend trying to do with the smallest value, which is the first equation. So this would be 48 equals u1, which we don't know, plus 8 times the common difference, which we already know now is 9, right? So this is 48 equals u1 plus 72. So u1 equals 48 minus 72, which is negative 24. So there we get the two same results we got here, right? Now, there's a third way you could solve this. I'm going to separate this once again. This also. The third way, let's do it with orange, is by doing a modification of the formula. You see that the formula is un equals u1 plus n minus 1 times d. If you understood well where this formula came from, which we saw here from this reasoning over here, you will understand that this negative 1 is written there because we have u1 here, okay? So if we make a modification of this formula in order to adapt it to the pieces of information we have here, u9 and u12, we could rewrite this formula by saying the following. u12 equals u9 plus 12 minus 9 instead of minus 1 times the common difference. Okay, this is a modification of the formula which is valid. You can do this reasoning without any problem. So we know that u12 is, how much is u12? 75, right? Yes, 75 equals u9 was 48 plus 12 minus 9 is 3d. So once again, 75 minus 48 is 27 equals 3d. So then d equals 9. And in order to find u1, we can do the same thing we did in the previous case. We just plug in into any of the two equations and we get the value of u1. So I'm going to do the same thing here without having to rewrite the same thing. Okay, and that's it. So those are 3 ways you could solve. Obviously, you can pick one and use that every time you need to. I don't recommend doing this. It's very long and you usually need the calculator to solve it this way, so it's not recommended. I would rather think about this way, which is a more theoretical way to solve the problem. Or maybe this one's also valid, but it may be confusing for some of you, so I would just stick with this solution. Okay, so that's it, people. If you have any doubts, remember you can always ask anything in the Google Classroom. See you.